Hey everyone, welcome to another lesson. Today we're going to be going over object-oriented programming and what it is. So, what is object-oriented programming? Object-oriented programming is this idea or theory where everything structurally is an object. Java is one of those unique languages that is actually object-oriented. What that means is that practically everything that makes the language Java is an object, and anything you create technically needs to be an object in order to function properly. So, what is an object? An object is something that has procedures and data that can be called, accessed, and manipulated. Formally, the procedures are called methods, and the data are called attributes, naturally stored in variables. So, the base object in Java is quite literally object. If we take a look at this image that I found really quickly on Google, let's pretend that this class right here doesn't exist, and this is at the very top of the hierarchy. This would be what we call the object class. And it sort of dives into a little bit about inheritance, and we'll get into that a little more later, but it's practically the object. So everything inherits from objects, so this class gets object. And what object is just the base foundational class that makes a class a class. And it's somewhat hard to understand if this is your first time diving into programming or object-oriented programming or anything in regards to like Java, but it gets easier as you go. But just know that the base object in Java is object, which isn't hard to remember. But with objects, there exists inheritance, in which an object can inherit from another class. An easier way to understand this is to think of objects like a family tree. If object 2 inherits from object 1, then object 2 has data and information passed on from object 1 that it can use the same way we inherit traits from our family members. So, for example, let's say this is object, and then this is person 1. And let's say person 1 has brown hair. And this is person 2, and person 2 inherits from person 1. Person 2 now gets the same traits from not only person 1, but also object. So the data, information, the methods, all of that gets passed on only because we inherited. There's a special way to inherit. It's not automatic. You have to tell Java that you want to inherit. And so that's practically inheritance. So why do we use objects? And more importantly, why are they efficient? So objects store our methods and data in a single place. Because each object has its own reference in memory when instantiated, each object can also carry unique information and data specific to that object. Now, in order to help us understand this and what I've said so far, I created this short little program. And all it does is it's a ball, and it bounces around on the screen. We can take a look at that in a second. So there's this ball and it's bouncing around the screen. Now, in the background, ball is actually a class. So this ball right here is a class. More specifically, it's actually an object. And this is an instantiated object. And the way we can tell is because there's this new and then the ball. We're actually calling the constructor method here. We're creating the ball, therefore instantiating it. Here we're just declaring it. We're saying ball. Now if you've never programmed before, we're not really worried about the syntax here and what this is actually doing, or what any of this means. If you do know, then maybe this is easier for you to understand. But if you don't know, then this might be a little harder for you to understand conceptually. But I think you can do it. So, to reiterate, the ball here is an object, essentially, instantiated from a class called ball. It has data, so it has a position, a velocity, and a radius. and it has methods update and show. And we're calling these methods here in order for this to actually run, and we created the ball here. So the ball is the object, has a position, velocity, and radius. Now, is draw an object? So this right here, is this an object? The answer to that is no. This is a method. This is the procedure that I was referring to earlier. It's manipulating objects, data, information, things like that, but it's physically it's not an object because it doesn't really have a place in memory. So we couldn't, I mean, technically we could create variables inside this method, but I wouldn't be able to access it. So I wouldn't be able to access stuff in here that I put in draw from setup, because this is also a method. They're both methods. So regardless, I wouldn't be able to access anything. Now you might be asking, well, you're accessing ball here and you created ball here. Well, this dives into like scope, which we'll refer to later, but technically I'm creating ball here. So that's why I can access it. But if I were to create something like int test is equal to 1, and then we said we tried to access it, so test plus equals 1, this won't work. We should see an error. So see, variable test does not exist. That's because it's a method and not an object. If I were to put test here, and then we come here and we say ball.test plus equals 1, now we can see we don't get an error, and the reason for that is because ball has an attribute called test, and that's why we can access it, because ball is an object that we can reference to in memory. Objects should typically be thought of as the foundation to provide attributes, data, and actions. Methods should typically be thought of as actions that act upon or manipulate data when asked to. So like if you're trying to make something that adds two numbers together, should you make an object or should you make a method? The answer to that would be make a method. You're manipulating data and you're taking two numbers, adding them together, and then giving that to the user. So that's manipulating data and then returning it. Now, if I said make a calculator that can either add, multiply, divide, things like that, should that be an object or a method? The answer to that would be an object, because the object would be the calculator, the methods would be the adding, multiplying, dividing, things like that, and the attribute would be the numbers that you put in, return the answers, things like that. So that's what object-oriented programming is. For example, if we were trying to make another ball, and I wanted to make another ball, but I didn't want to write. So like, let's say we put all of this code right here. We put all of this here and got rid of the ball object. And we did that individually. So we took the position and we added the velocity and we drew the ball. We did all of that here without the ball object. And we removed all of this and we put that update code here. If I wanted to create a ball, I would have to copy all of that code and make a v2 sort of version of it. So there would be a position 2, a velocity 2, a radius 2. I would have to do all of this code for the second one, and then I would have to draw it. What if I want 3 balls, 4 balls, 5 balls? That's a lot of copying and pasting, and that's a lot of versions of like different variables. With objects, all I have to do is create a new object. I just have to say ball 2, and then I can literally just copy this, paste, and then all we have to do is remember to update and show. Now if we run this, well, wait a minute, why aren't there 2 balls? Now that's an easy answer. That's because they're overlapping each other. They're going the same speed in the same direction. So if I just change the velocity to go in the opposite direction, now we have 2 balls. Now, some of you may be asking, well, technically you're doing the same thing. You had to copy the code, the exact same code for the second ball. What if I want 100 balls? that's going to be 100 versions of each thing. Now, yes, you're right, but with object-oriented programming, there's actually a more efficient way of doing it. So, if we got rid of ball and we made ball an array, we have an array of balls. And then we said ball is equal to a new ball array of, say, we'll make 100 just because that's what we specified it as. Okay, so what I just wrote is essentially we're taking this array of balls of size of 100, and for each space in that list, we're creating a new ball and we're putting it in that list, and then we're saving that in memory. And then while we're going through the draw loop, we're going through each space in that memory, and for every ball that we saved, we're updating and showing. So this is practically an easy way of creating 100 balls without copying and pasting each and every piece of code. So if we run this again, we now have 100 balls on this screen without having to copy and paste 100 of each and every single line of code that we want in order to manipulate it. So if, say, for example, there's a bug or something and you have to change something, but you copied and pasted it for 100 different things, you now have to go through each and every 100 of those things and change it. Whereas here, I can just, so like say for example, maybe I want to update before I show. I could just move show up above update, and that would be it. I wouldn't have to go through each and every single one, copy, and then like put it up. I wouldn't have to do any of that. Maybe I don't want them to start at the middle of the screen. Maybe I want it to start 1/3. Well then, in that case, all I have to do is just update that one line and all of the balls get updated automatically. So this is the power of object-oriented programming, this idea that we can create objects and then have specific data and attributes stored in these objects while also being able to create them efficiently and create sort of things like this. In terms of like WPI, we actually did this in our camera code. So we didn't really know how many cameras we wanted, and it sort of depended, but it's a multi-camera subsystem. So here we can see that we have a camera list, a USB camera. So it's an array of USB cameras, and we're actually going through each one and storing those objects there. So there's a camera count. So maybe I can say I want 3 cameras. Well, then it automatically creates 3 cameras and saves it in this array. Maybe I want 2, maybe I want 1. That way I don't have to copy and paste all of this code for each and every camera. And so that's why it's crucial to understand what objects are, how they're used, and how they can be efficiently used, if anything, because that's their whole purpose, is to make things efficient and easy. That way we can store data and information and then reference it later. So yeah, that was a lot of rambling, a lot of information to take in, and it'll definitely get easier once you are able to like get your hands on it, like actually see it happening and understanding how it's happening by writing your own code. And if anything, if you know how to program, I would say try to make something sort of like this. It doesn't really have to be like this. You could try the calculator app that I was referring to. But if you don't know how to program, we're actually going to be diving into the Java basics in the next lesson. So you'll be able to learn how to make things like this and the foundational tools to making Java programs. Cool. I'll see you guys in the next one.